Assalamu alaikum. How are you, everybody? Today we gonna start our class for the thermal fluids engineering lab. As you know, we have 10 labs for this semester, and we will start for our first lab today. So our lab today is about the buoyancy. It's just to the aims or demonstrate the concepts related to buoyancy and floating principles. So we have three materials here: brass, aluminum, and polymer. We will need to know how the buoyancy happen. So the buoyancy, it's mean, as you know, the ship or when it's go with the sea, why the ship is not fall down, just be up to the water, because as you know, the material that is made of the ship or of the ships, it's like the density of the materials is like light more than the density of water. The density of water, as you know, is constant, which is 1000 kilogram per meter cube. So here now we will try to know how the buoyancy will happen for these three materials. For this experiment, we will try to figure the force of the buoyancy, which is called lifting force, which is make the material is light more than with the usual. So first of all, I will try to take the weight of the materials, then I will try to do it again when it will be with the water. We just try to, it's okay, no problem. First, I will try with the brass. As you see here, the brass now is constant, which will not increase more. The force of the brass, its count is 4.5 Newton. Let me try now with aluminum. The aluminum now it's 2.6 exactly. The third one, which is the polymer, it's the light one that we have in here. It's 1.3 Newton. So now we take the force that it affects in regular one, the weight force. So now we will try to take it again with when it will be in the water. So we will notice that the water, it will help the material to go up, not to go down, what is called the lifting force. Here just we have to calculate the volume also. So right now the force is 4 exactly. So the force weight with water, it's gonna be 4. For the experimental, what we will do is just the weight force, like here was 4.6 and here was 4, or so that the experimental it will be 4.6 minus 4 or 4.5 minus 4, so it will be just 0.5 or 0.6. The volume just is not accurate, which is between 40 and 60, it's almost 50. We can say it's 50 milliliter. To convert from milliliter to the meter cube, we have to convert it first from milliliter to the liter. So we have to multiply it with 10 to the power negative 3. Then from liter to the meter cube, we have to multiply it again with 10 to the power negative 3. So the total is 10 to the power negative 6. We will do it again now with aluminum and the polymer. The polymer is too light, which we need to maybe just to rise the water tank up. This is the aluminum. The aluminum actually is just check it again. It's 1.7 exactly. So now 2.5, I think, minus 1.7, it will be 0.8. I think that's so. We will try now with the last one, is the polymer. We will add the polymer. See, we have just to rise the water up. It's 0.7 actually, or you can see 0.6. The both polymer and aluminum, it has same volume distance, which is all of them is 80 milliliter. So right now we have the weight force water, experimental weight force, experimental lifting force, volume. We need just the theoretical lifting force and the density of the material. We will do that with calculating together. So that's all for this video. Thank you for watching.